So this is a uniform motion problem. So for those we use rate times time equals distance. And you also want to remember if you divide both sides by r, you get t equals the distance divided by the rate. So we're going to need that piece of information. All right. Mary Ann just returned from a visit with her grandchildren back east. The trip was 2,400 miles from her home, and her total time in the airplane for the round trip was 10 hours. If the plane was flying at a rate of 500 miles per hour, what was the speed of the jet stream? Well, we usually set up a chart for these. So we have the rate times the time, rate, time, and distance. So she's flying with the wind. That's the jet stream, is the wind. So, the wind is helping her go faster in the plane. And then she's flying against the wind. And I don't know which way the wind's blowing, but it doesn't matter for our purposes here. Okay, so the plane on its own goes at a rate of 500 miles per hour. So when you're flying with the wind, you're taking the 500 plus W. I'm using W for wind. You could use J for jet stream. But when you're against the wind, then it's the 500 miles minus W. Then the wind is slowing you down. Time, well, we know it takes a total of 10 hours for the round trip. So hold that thought. I'll put a 10 down here. We don't know how long it takes for each leg of the journey, how long it takes to get there and how long it takes to get back. We just know that the total trip is 10 hours. Okay. And then the distance. When it says the trip was 2,400 miles from her home, I think they mean the grandchildren's house is 2,400 miles. So wherever she was going was 2,400 miles. Okay, and it's 2,400 miles there and 2,400 miles back. Okay, so we're going to use that idea of distance over rate. So the time, I'll make this a t sub 1. Okay, that time is going to be 2,400 divided by 500 plus W. And then I'll make this time 2, because we don't know what it is, but time sub 2. Probably not the same time as time 1, because one way is going to take longer than the other if you're flying against the wind. One way. That's going to take longer. All right, so time 2 is going to be 2,400 divided by 500 minus W. So it's the distance divided by the rate. Now, if you take the two times together, so T1 plus T2, that has to equal 10. So 2,400 over 500 plus W plus 2,400 over 500 minus W, that's going to equal 10. Total of 10 hours. Well, this is an equation with rational expressions, so I'm going to multiply by the LCD, which is going to be, my LCD here, it's going to be 500 plus W times 500 minus W. So it's kind of big here. It's a little tricky to write all this out. All right, so now I'm going to have 2,400. I'm going to be bringing this in times this expression. The 500 plus W is going to cancel, and then I'll have 2,400 times 500 minus W. Plus, then I'm going to bring it in here. I'm going to have 2,400. The 500 minus W's are going to cancel, so 500 plus W equals 10 times 500 plus W times 500 minus W. So that's the LCD times 10. Okay, those are some numbers. All right, see this 10 right here? I'm going to divide both sides by 10. That means dividing each term by 10. That's going to make my numbers smaller. So 10 goes into 2,400, 240 times. 240 times 500 minus W plus, and then the same thing's going to happen here, 240 times 500 plus W. And then over here we'll just have the 500 plus W times 500 minus W. Okay, now we're getting somewhere. The numbers are still a little large, but that's okay. So I'm going to distribute here. That's going to give me 120,000. Yeah, okay. Minus 240W plus 120,000 plus 240W equals, now you might notice this is the difference of squares, right? So 500 times 500, that's 25 with 4 zeros. 250,000 minus W squared. You don't have a middle term because it's going to drop out. Okay, now on the left, the negative 240W and the positive 240W, they're out. That number, 120,000 plus 120,000, that's 240,000 equals 250,000 minus W squared. Well, if I put the W squared on the other side, on the left, and if I subtract the 240,000, I'm going to have 10,000, like that. And then I could just take the square root of both sides. But this is a nice one because I know the square root of 10,000, that's just going to be 100. Now, I put that square root on there, but I didn't put the plus or minus. And why is that? Because the wind is not going to have a negative speed. It's got to be a positive number here. So the wind, or the jet stream, is 100 miles per hour. It's going at 100 miles per hour. So some big numbers there, but doable.